In today's economy, delivering a product effectively is no longer the ceiling, it is the baseline. As customer expectations rise and supply chains fracture, continuous improvement becomes a requirement for survival. Take Thutuka Manufacturing, a plastic packaging plant facing a cascade of failures. When their injection equipment seizes up, the entire factory floor descends into chaos. The internal failures are compounding. High scrap rates are bleeding the raw material budget. Machinery breaks down frequently, and skilled operators required to reset the equipment are resigning in frustration. The macro environment offers no relief. The regional power grid is highly unstable, subjecting the plant to unpredictable rolling blackouts, known locally as load shedding, that instantly stop production momentum. This radar chart maps 5 core performance objectives: quality, speed, dependability, flexibility, and cost. At Thutuka, defective plastic pulls quality inward. Machine jams shrink dependability and speed. The entire operational footprint is contracting. A perfectly funded corporation would solve this by deploying massive capital to purchase a new, automated line. Thutuka lacks that capital. They're trapped with their current aging equipment. Frameworks like lean and total quality management offer solutions, but applying them here requires aggressive, localized adaptation. You cannot outspend a flawed process. You must systematically outthink failure points through continuous improvement. When managers recognize a failing system, they rely on 2 primary engines for executing improvements. This panel highlights 2 approaches. On the right is breakthrough improvement, a radical, high-cost step change equivalent to bulldozing the factory floor to install robotics. On the left is continuous improvement, or Kaizen, targeting low-risk, incremental gains through daily problem-solving from frontline staff. Given their severe capital constraints, Kaizen is the only financially viable strategy to rescue Thutuka's operation. The first critical target is the scrap rate. Producing defective plastic containers wastes resin, energy, and labor time. To attack this, managers apply the philosophy of total quality management, or TQM. TQM demands that quality is engineered directly into the assembly steps, rather than just inspecting bad parts at the end of the line. This requires process orientation. If a defective unit reaches the loading dock, the error originated hours earlier, hidden within the system's architecture. TQM uses a fishbone diagram to hunt hidden root causes. We place the scrap rate at the head, then trace variables backward. We isolate the methods branch for machine temperatures and the materials branch for inconsistent plastic. Quality control becomes proactive when it shifts focus from simple end-of-line detection to designing a process that prevents manufacturing defects at the source. Eliminating scrap only matters if the factory has the capacity to run. Thutuka's second critical failure is unreliable machine performance and constant downtime. Before engineering a fix, managers must separate the normal operational background noise from actual systemic errors. This is a control chart. It plots downtime over a set period, establishing boundaries for acceptable performance. Data points bouncing between these limits represent common cause variation, standard harmless operational friction. But when a data point pierces the upper control limit, it triggers a special cause variation. This is a definitive error that requires an immediate halt and investigation. Once the data isolates exactly where the errors occur, managers turn to lean operations theory to eliminate them. Lean operates on a single objective: maximize customer value by relentlessly eliminating muda, or waste. This table categorizes operational waste. The plastic scrap represents defects. Operators standing idle represents waiting. Lean destroys these wastes using tools like Jidoka. By installing simple sensors, the molding machine automatically halts the instant an abnormality occurs, preventing a single defect from multiplying into a massive batch of scrap. To counter breakdowns, operators execute the 5S methodology, standardizing and cleaning their workspace. In a clean environment, a minor oil leak or a fraying belt becomes highly visible long before it triggers a catastrophic jam. Lean tools strip away the clutter. They create a transparent environment where physical waste and mechanical failure have nowhere to hide. A lean, optimized factory floor will still fail if the local macro environment collapses. In Southern Africa, efficiency theories must be armored with a mandatory layer of local risk management. To survive load shedding, capital is diverted into hard resilience. Factories invest in dedicated backup power tailored to endure rolling blackouts. This localized adaptation extends to human capital. corporate social responsibility becomes an operational necessity for survival. Management stabilizes the critical manpower variable on the fishbone diagram by viewing CSR-driven initiatives, such as improved ventilation and competitive benefits, as direct investments in workforce retention. The ultimate financial justification for these localized improvements lies in managing the cost of quality. It is a common misconception that manufacturing a superior product necessitates permanently higher operating costs. This chart shows a failing plant's cost structure, consumed by internal failure costs and external failure costs. The solution is the quality cost inversion. Upfront investments in prevention costs force a massive collapse in downstream failure costs, reducing overall capital spent. Thuthuka used Lean to eliminate waste, TQM to engineer defects out of their process, and local risk and CSR strategies to shield their operation from a volatile environment. These precise operational controls are used in advanced manufacturing facilities, like the high-end automotive assembly lines operating across the region today. The scale of the global supply chain and the ports that sustain it rely entirely on the output of these optimized, localized facilities. True operations excellence is achieved only when an organization turns continuous improvement from a set of theoretical tools into a fundamental, localized survival reflex.